Wind is the driving force of our weather. It brings the change between sun and rain. But with climate change, the wind is also changing.
The winds are bound to change as temperatures rise.
In the USA, hurricanes are getting stronger and stronger, and they devastate ever larger areas. Weather disasters are also becoming more frequent in Europe because climate change affects the jet stream, a band of strong winds at an altitude of 10 kilometers.
The jet stream is like a guide, is a highway for storms.
The high-altitude wind is influenced by the temperatures in the Arctic. The developments are alarming.
We know that winds tend to increase and extreme weather situations occur.
Wind is a movement of air caused by different temperatures or air pressures, but it is changing. According to various studies, the wind speeds of winter storms are increasing by up to 5% in Central Europe. At the same time, the storms are lasting longer than before. The damage they cause is becoming greater. This can be seen clearly in our forests. 17% of the protective canopy has disappeared from European forests in the last 30 years. This is also due to storms becoming stronger. Stocktaking in a forest area in Mecklenburg-Western Pomerania. Heiko Schulz and Mattis Janssen inspect a stand of spruce trees after a storm passed through here. First, rain fell. Then the hurricane came from the Atlantic. The trees snapped or were uprooted.
A lot of rain before a storm event always has the risk that there's more damage.
The roots don't have the strength anymore. Everything just slips through.
The fact that the damage left behind by storms in the forest is visibly increasing is also due to the extreme summers. The heat takes its toll on the trees. This makes them susceptible to insect pests. Once the trunks are infested, they become brittle, and the storms have an easy time with the trees, a vicious circle. The fallen logs need to be taken out of the forest, because every dead tree that lies in the forest becomes a breeding ground for insects. Dead wood cannot defend itself against pests that eat into the bark. They multiply. Healthy trees without heat stress react with resin and can fend off a whole lot of attacks.
There clearly was a jewel beetle, arranged like this, in contrast to the longhorn beetle. The lateral margins are quite sharply truncated, quite different from the bark beetle.
That's a typical picture.
That's typical. It's an insect that will benefit from climate change, as it's a heat-loving insect that can locate weak and damaged stands over a distance of kilometers. I think it's about 20 kilometers, and it's on the advance.
Climate change is causing a dangerous chain reaction in our forests.
The storm brings the best conditions for a later infestation of this pathogen, as it provides the opportunity for the insects to find breeding material. If it's not quickly cleaned up, as is the case now, for example, in October 2017 there was Xavier, a bad storm. There was a lot of wood on the ground in fall. We just couldn't work that up in so little time. So in spring there still was some in the forest. Then the bark beetle, which flew out in April and May, found the best material to develop there with the corresponding temperatures.
In order to save the forests, the storm damage would have to be removed quickly in the future. But this requires more machines and personnel. In southwestern France, the wind reaches the coast unchecked. Even here at the Atlantic, things have already changed. In Soulac-sur-Mer, they regularly clear their streets of sand. It has to be returned to the beach, otherwise it will be missing as protection in the winter when the storms push the sea against the coast for days. Rising sea levels are also making themselves felt here. In 2014, a series of winter storms caused metre-high waves. This apartment block was in danger of falling into the sea. Since then, they've put artificial breakwaters in the sea in many places and raised the dikes. But this has not solved the problem. Researchers believe that the peak speeds of the storms will become higher here in the future. The region's coastal observatory assesses winter damage anew each spring.
Let's go over there and set it up.
Thomas Bulto and his colleagues installed their measuring devices on the beach at Biarritz. They couple their base station to a satellite via GPS, which not only measures the exact location of the device, but also its distance from sea level.
The measurements have become necessary as our coastline changes extremely every year. The shifts threaten the coastline in some places. Only through regular comparative measurements can we assess the development. Our data provide a robust basis for planning and risk management at the threatened coastal sections.
On this stretch of coast, offshore rocks in the sea protect the beach. And yet, the force of the storms has long since made itself felt here, as has the rising sea level. During strong storms, sections of the cliff simply break away. The beach is affected by two opposing forces. The wind carries the sand away and blows it inland. Storm surges wash it towards the sea. The beaches here become shallower by a few millimetres every year and continue to level off with sea level.
When we have storms in close succession with heavy precipitation, as recently in December, we also see large movements on the coastal lines. The precipitation accelerates the ground movements. This shows that not only the sea but also the wind and the precipitation have an impact on the Basque coast.
Il peut aussi y avoir des conséquences des tempêtes sur simplement la pluviométrie qui peuvent avoir un impact sur le littoral rocheux basque.
When the beaches become shallower, the sea has an easy job of it. It works its way deeper and deeper into the cliffs. The first beach location is in danger of being lost. Defending it against future storms would cost billions.
I think society has to come to terms with relocating houses and people. At the moment, the legal and financial framework is lacking to implement such a solution. But in the end, it is foreseeable that a harmless life on the coast will only be possible if more leeway is given to nature. But to do that, we have to retreat further. I think that's realistic.
En étant un peu plus en retrait, qu'on arrivera à vivre durablement sur le littoral, qui est bien réel.
At the Potsdam Institute for Climate Impact Research, scientists are investigating the effects of climate change on our weather. Are extreme heat waves, continuous rain and stronger storms related to each other? Effi Russi and Stefan Ramstorff are looking for the answer in changing wind patterns.
Until now, we have seen some changes, and actually what we have seen is very much dependent on the region and the season. So, for example, for winter, we do see a strengthening of the storm tracks, especially over northwestern Europe. In summer, we see the opposite. We see a weakening of the storm tracks.
Die Winde werden sich zwangsläufig verändern.
The winds will inevitably change as temperatures rise because, after all, the Earth is not warming evenly everywhere. And the winds are driven by temperature differences between different regions. And therefore it's quite clear that the wind conditions will change due to global warming. And that, of course, will also have an impact on people.
Erwärmung verändern werden. Und das hat natürlich auch Auswirkungen dann auf die Menschen.
The impetus for our weather blows around the Earth at an altitude of about 10,000 meters. The high-altitude wind is created because warm air masses move from the equator to the colder north. The Earth's rotation directs these air masses around the globe from west to east. A first wind band is formed near the subtropics. A second, stronger one forms around the 60th parallel. It draws its power from the temperature differences between warm air from the south and cold air from the North Pole. This North Polar jet stream drives low and high pressure areas across our latitudes in its loops. Researchers have observed that it is slowing down more and more often.
The Arctic regions have been warming faster in low levels, so near the surface of the Earth, compared to the rest of the globe. So practically this means that this temperature gradient, so the differences of temperature between the poles and the equator, become smaller compared to the past, to the normal. And when we have smaller differences, this would mean weaker winds and weaker jet streams.
The Arctic. Over the last 50 years alone, it has warmed by 3 degrees. That is significantly more than the entire Earth. Since the beginning of industrialization, its temperature has increased by about 1.1 degrees. On Spitzbergen, meteorologist Marion Maturilli of the Alfred Wegener Institute is studying what is leading to the faster warming in this region and what effect this warming has. She also coordinates all the scientific work being done here at the Franco-German station.
Research in the Arctic has become more important, also because climate change is progressing more clearly in the Arctic than in other regions of the world. And here in Ny-Ålesund, there is simply the possibility in various areas to measure and document the effects of climate warming, and also to study the individual processes.
Ny-Ålesund is the name of the settlement in western Spitzbergen. The village is an important center of climate research. 11 nations operate scientific facilities here. The observatory of the German-French station is full of measuring instruments. Maturilli has already detected the first consequences of the temperature rise.
Especially in the winter months, we can see that the air currents come more often from southern directions, which now bring air from the mid-latitudes, carrying warm and humid air masses. This also has an influence on precipitation, on the clouds that form here. And that, of course, is changing the climate here locally, and that's a concern. I'll go ahead and fill up the balloon with the gas.
Wind changes continue to heat up the Arctic. Environmental engineer Fika Rada supports the scientists in their studies. Every day at noon, she launches a balloon carrying a measuring probe that sends weather data to the Earth. Maturilli is using the data to determine how Arctic temperature increases affect the jet stream. To gain long-range insights into the high-altitude effects of global warming, such balloons launch simultaneously at different places on Earth. They fly up to 30 kilometers before the rubber shell bursts.
For my measurements, they are very important because it is actually the only measurement that reaches 30 kilometers altitude, and the altitude resolution is also very high. The balloon ascends at 5 meters per second and has a reading every second. That means we really have a reading every 5 meters, and the other instruments can't get that.
Maturilli's measurements showed that the jet stream has changed. When the wind changes, it inevitably affects the living creatures on Earth. In a forest near the village of Chizé lies one of the most important ornithological research centers in France. It is from here that Henri Weimerskirch regularly sets out on his expeditions to the far corners of the Earth. In a breeding colony on the Crozet Islands in Antarctica, he's been studying wandering albatrosses for years, which raised their offspring there. In 2012, he made a discovery.
Analyzing our long-term data, compiled over 20 years of bird observations, we noticed changes in the movement patterns of albatrosses. We also noticed that the birds' reproductive success had improved. Even the average weight of the birds while rearing young has changed.
On average, the adult birds weighed a good 1 kilogram more than 20 years earlier, without the animals having grown any larger. The number of albatrosses in the breeding colony also changed. More chicks survived each year. The researchers only discovered the reason for the changes when they began to analyze the region's weather data from the past 20 years.
This was due to the change in wind conditions. We could prove that the flight speed of the albatrosses had increased. Due to the higher wind speeds, the birds flew significantly faster. This also increased the weight of the birds. They expended less energy foraging because they found the same amount of food in less time. They therefore gained weight.
The albatrosses benefited from a westerly wind flow that had shifted further toward the South Pole due to increased temperatures. It was discovered by chance, but proved for the first time how massively changed wind conditions affect life on Earth.
Climate change's impact on animal behavior was completely underestimated until then. In particular, that it can change the rate of locomotion of an animal was very surprising to us.
How drastic the effects of wind changes can be is already being felt by our farmers. The change between rainy and dry phases, which is important in our latitudes, has become more irregular. Farmers are increasingly having to contend with crop failures. Farmer Jan Wittenberg therefore relies on plants that can also cope with weather caprices.
Lupin has excellent root growth. This goes very nicely into the depth with a taproot and is thus able to unlock water reserves that remain hidden from other plants. In addition, it also improves the structure of the soil so that other plants then subsequently also do well. And in fact, last year, which was the second super dry year with us, only lupin brought top yields, although it was so dry, and all the others, especially the cereals, almost failed.
Climate change is no longer a pipe dream from distant worlds. It has long since arrived in Europe. At the latest, the heat-wave summer of 2018 opened the eyes of even the last farmers. The wind had not driven rain clouds over the fields for weeks.
We've been discussing the problems with the climate and the fact that there will be weather extremes for a long time. And unfortunately, there were still people who didn't want to admit it. But I think that was the signal for all of us at the latest. Now it's getting really serious. The weather has already changed and we have to get ready for it.
Jan Wittenberg in Lower Saxony responded to the changes years ago.
I haven't ploughed at all in over 20 years because I'm convinced that no-tilt farming is better for the soil, the plant and the whole system. For one thing, it allows us to better infiltrate extreme rainfall events into the soil. That means water can infiltrate nicely down through those vertical corridors and then deep into the soil. And on the other hand, we don't have as much surface transported away by wind and water.
The lupine has just been sown. The canola is already in full bloom. Wittenberg's goal is to spread the harvest over as long a period of the year as possible.
We have to try to adapt. That means we have to adapt our crop rotations, grow other crops and above all, grow many different ones. The diversity has to increase, so we share the risk. So risk decreases when diversity increases.
Are extreme summers in Germany a consequence of changes in the Arctic? Marion Maturilli is looking for the answer to this question on Spitsbergen. In weather that is far too good. In September, it was often above 0 degrees in the past, but the fjord was rarely completely free of ice. But those times are over. Even in winter, a closed layer of ice no longer forms here. Meteorologists and her team are on their way to another measuring station. Here, the scientists filter and analyze particles that the wind has driven in. Pollutants in the air that make it clear how much the wind systems connect the world.
Pollution is also measured here, which is transported here over long distances, again with the wind, of course. At the end of the day, pollution from industrial regions or even from Siberian forest fires also gets to the Arctic and is measurable here.
Next stop is a glacier on the eastern shore of the bay. The ice in the fjord comes from it. The edge continues to break away. The glaciers on land are also retreating. As a result, the sea level is rising. But compared to the South Pole, the masses of glacial ice here at the North Pole are small. Meteorology considers the disappearance of the ice sheet on the oceans to be more serious.
When the sea ice retreats, has a smaller extent, it means that more water surface is exposed. As a result, less solar radiation is reflected simply because you don't have the white surface. Instead, you have the dark water surface absorbing heat and further heating the ocean atmosphere ecosystem. So that's a feedback, and also the exposed water surface is also conducive to more evaporation into the atmosphere. That is, the atmosphere becomes more humid and also warmer overall. That has an effect on cloud formation, among other things, and that in turn has feedback effects, so the climate warms.
Another effect that makes the Arctic warmer. But does it really affect the jet stream? At the Alfred Wegener Institute in Potsdam, climate modelers process data from meteorologists in the Arctic. They calculate whether what is happening there is accelerating climate change. Meteorologist Dörte Handorf also keeps an eye on the Arctic sea ice. She evaluates satellite photos.
We can see from these curves that the sea ice is decreasing relatively continuously. If we look at the sea ice values for the individual years for each month, so here, for example, again for September in the sea as a minimum, we see that the sea ice has decreased since the late 1970s, and this negative trend is about 13% per decade.
Without sea ice in the North Polar region, the Arctic will heat up much faster. Dörte Handorf has calculated this effect into the climate models and looked for consequences for the jet stream.
We have shown that reductions in Arctic sea ice cover can have an impact on the jet stream by showing that for lower sea ice cover, the jet stream weakens in late winter, and blocking weather patterns occur more frequently.
Blocking weather patterns occur because the slowing jet stream is no longer pulling as tightly around the Earth. Its loops increase in size and come to a standstill. High or low pressure areas remain over a region longer than usual. There's no longer an alternation between the red high and the blue low pressure areas. This can lead to extreme weather events. Such fluctuations in the jet stream have always existed, but the Potsdam researchers have proven that climate change can trigger them with catastrophic consequences.
There's a very clear connection between the jet stream and extreme events. For example, there is a phenomenon that sometimes very strong loops, oscillations in the jet stream from north to south occur, which then stop on the spot. That then leads to very long-lasting weather situations. If it is rain, then it can lead to floodings. And if the prolonged weather pattern is high pressure in our area, it can lead to heat waves and drought.
We don't know yet whether those weak states of the jet stream are becoming more frequent or different. However, what we can say is that even small changes in the jet stream, even if it is a little weaker in summer, for example, could bring disproportionate impacts on the surface and on extreme weather.
So, changes in wind patterns were the cause of extreme heat waves and droughts like in the summers of 2018 and 2019, with high-pressure areas stuck in the weakening jet stream. If low-pressure areas sit in such jet stream loops, this can lead to unusually long and heavy continuous rain, as was the case with the disaster in the Ahr Valley. But when is a single weather event really related to climate change? In Potsdam, Martin Kreienkamp of the German Weather Service calculates these correlations. Attribution research is the name of this new branch of science.
We use climate models and simulate the state as it is now, where we are as humans, with all the changes we have caused. Then we take the same climate model and simulate it as if humans had had no influence. Greenhouse gases, land usage. And when we compare the two models, do we see a change or not?
The severe weather disaster resulting from heavy continuous rain in Germany was one of the largest extreme weather events of 2021. Attribution researchers compared the rainfall masses in their models.
Climate change has had an influence in the flash flood triggering events in Ahrtal-Erft. It has increased the probability by a factor of 1.2 to 9 compared to pre-industrial levels. We don't give a precise number there, as our information aren't precise. But there's an example. It currently occurs every 400 years. But if we take a number like 5, for example, then without climate change, it would have occurred every 2,000 years.
Princeton University in the US state of New Jersey is one of the world's most renowned research institutions when it comes to understanding climate change. Professor Tom Knutson and his research group study hurricanes and how climate change alters them. And he calculates what this means for people living in regions where hurricanes occur more often.
We're expecting that hurricanes are going to be more intense as the climate continues to warm. That's not a huge effect. The size of that effect is something like 3%. Now that 3% in wind speed implies a greater percentage increase in damage, by the way, because we think damage from hurricanes goes up not just linearly with wind speed, but perhaps as the third power of the wind speed. So that really may indicate something more like a 10% increase in wind damage potential.
New Orleans in the state of Louisiana. The debris in the streets and the blue tarpaulins on the roofs signal a hurricane has struck here. Exactly 16 years after Katrina destroyed large parts of the city, the region was hit again by a hurricane. Ida, a hurricane of the second highest category, swept through the city at about 240 miles per hour. It will take time to repair the damage. For D'Artagnan Stovall, August the 29th, 2021 was the day he became homeless. He's found shelter with his brother.
It's difficult to stand here and look at it. And you know, so many memories, so much work that I did on the house. My family had been here since 1978, so it's been quite a while. It's surreal. That's the only word I can really find to describe any of it. As you look at the other houses, you think maybe I'll have some roof damage, or it's a funny thing. It just, my house fell. This is just unbelievable.
The storm reached Louisiana on the morning of August the 29th. Meteorologists had warned of it, but evacuation was out of the question for many citizens. D'Artagnan Stovall also remained in his house and hoped that the storm would pass. He was on the top floor when a gust of wind hit the house and tore the walls apart. He freed himself from the rubble.
I'm up in the air with a lot of it because I'm deciding if I stay in New Orleans. The entire process of hurricane preparedness and kind of hunkering down or deciding to go somewhere else, and they seem to be occurring more often. And like this was the anniversary of Katrina, the 16th anniversary, and you just get tired of the process. Even when you don't get hit by it, the prep to deal with it.
Ida hit people with full force, and in the future, hurricanes could be even more destructive.
Another effect that we're expecting out of hurricanes is an increase in their rainfall rates, because a warmer atmosphere holds more water vapor, typically. So these hurricanes that are happening in this large-scale environment where there's more water vapor and the hurricanes are converging this water vapor in toward the storm. So we expect that to be about a 7% increase in rainfall rates for every 1 degree Celsius rise in the sea surface temperatures.
Hurricane Ida is something like the fulfilled prophecy of the climate change warning. The stormy depression moved along the east coast of the USA and brought with it enormous masses of precipitation. In the end, over 90 people died as a result of the hurricane. In Lambertsville, New Jersey, rain caused a creek to burst its banks, turning it into a raging torrent. The masses of water pushed the Caparulo's house off its foundation. The family of 4 had left it in time due to a storm warning.
To my left would be the children's room. My daughter and my son would have been, their rooms were right here. So that's where the water first came and hit and pushed everything out of the ground floor. We had a large hardwood floor, and it buckled into a V. And once the water came into the house, it pushed everything right out of there and right down the creek.
The Caparulo's house has since been demolished. The neighboring house can also no longer be saved. The municipality forbids rebuilding. The disaster could happen again. Above all, the dangers from rain masses which future hurricanes will carry are increasing.
The propagation speed of tropical storms and hurricanes over the U.S. land regions has decreased since 1900. When storms slow down, that means they're going to spend more time over any given region. So a storm that's going more slowly, you're going to have a greater accumulated rainfall in a region, which leads again to a more flood risk.
The European Organization for the Exploitation of Meteorological Satellites in Darmstadt. From here, the European Weather Services receive data that satellites measure in space. They are an important basis for weather forecasting. Paolo Ruti is the chief scientist of the facility. He works on improving the forecasts. So far, his employees have only been able to measure the wind in space indirectly.
We get very detailed information on the infrared and visible channels, and we derive this information. We have different clouds at different height, and so we determine the movements of the clouds, and from the movements of the cloud, we infer the wind vectors. It's important because it gives to the model the capacity to well position the storms and to well position the dynamics of the storms. So they move towards a certain part of the continent.
However, the satellite observations to date say hardly anything about the jet stream. A new measuring system is to change that. It's already been tested in space and is observing how the high-altitude wind influences the weather on Earth.
What is happening to the surface and what is happening to the 10 kilometers high are really extremely important to understand and to predict those systems. So those are the areas where we would like to have more and more observations. And we have now a kind of prototype who is already flying, which is called Aeolus 1, the god of wind. So, and is already giving us the possibility to understand these systems.
The European Space Agency, ESA, has developed the satellite and its new wind measurement system. A UV laser is to scan the area between the satellite and the Earth's surface. It measures the speed of movement of the molecules beneath it via their light reflection. The satellite has been orbiting Earth since 2018. At the Leipzig Institute for Tropospheric Research, Fridays are Aeolus Day. Holger Baas and Sebastian Bley regularly check the satellite's data here.
These are last week's measurements?
About 3 hours after Aeolus has flown over a region, its measurement data are available.
Each of these rectangles represents a wind measurement measured by Aeolus. Aeolus measures from the ground to about 30 kilometers up. We see blue colors now and these yellowish red colors. You can see that here on the scale, red colors show east wind in this example and blue colors show west wind.
Dark rectangles indicate strong winds. The dark blue agglomeration indicates the jet stream.
We see color changes on the ground. That's simply because there's a lot of turbulence on the ground, and so it's difficult to make very precise, very accurate measurements from space.
We'll see what the radio sonde measured.
Every Friday, the satellite flies over Leipzig. That's when Holger Baas and Sebastian Bley launch a weather balloon with a measuring probe.
To what altitude did it measure?
The radio sonde went up 24 kilometers.
So it covered the entire altitude from the Aeolus measurement.
The balloon probe from Leipzig measures more precisely than Aeolus, but only the satellite provides area-wide data on the jet stream.
Aeolus measures with a precision of 5 to 8 meters per second in the free areas. When you know you're going to have 5 to 8 meters inaccuracy, that's perfectly fine.
The German Weather Service in Offenbach. Here, the Aeolus data from space are checked and converted into weather forecasts. Alexander Kress thus had direct access to jet stream data for the first time.
We use the Aeolus in our global model. The jet stream drives the high and low pressure systems on Earth, especially in the Northern Hemisphere. And the better we can predict the path of the jet stream, the better we can predict the path of the low and high pressure systems.
If the jet stream slows down, extreme weather situations threaten to become more frequent. The data should help to better predict catastrophes in the future. Authorities would be able to initiate evacuations at an early stage.
That's a big step, to have area-wide observation, which one didn't have before. And if you take the last flood disaster, for example, such things will increasingly affect us in the next 10 or 20 years. And the better and more precisely you can measure winds over the Atlantic or in the Pacific, the sooner you can perhaps better predict such catastrophes in the long term and then warn people.
But predictions alone will not be enough to cope with the weather conditions brought about by changing winds. In Lower Saxony, a long dry phase is making itself felt in the fields of organic farmer Jan Wittenberg. The lupins are missing the rain in late summer.
These are actually good. These 3 and the other 3 are not fully mature. Without water, it's difficult for any plant. The lupin may be an expert, but with so little, it just reduces. It's a good product anyway. If you clean the little ones out now, you still have a nice grain quality. It's a good food. but just less. Nature reduces when one factor becomes scarce. And here, it's the water.
Die Natur reduziert, wenn ein Faktor knapp wird. Und hier ist es das Wasser.
Lupins are just one of 10 crops that Jan Wittenberg is pulling from his fields this year. He had already harvested a large part of the fields before the dry phase began. He refuses to irrigate fields in general.
There are crops that need irrigation site-specifically. There's no question about that. But to now react artificially to the increasing water shortage with even more water from above, I think is fundamentally wrong. There will be competition from drinking water to irrigation water, which nature undoubtedly needs.
Zum Beregnungswasser, vor allem aber auch zum Wasser, was die Natur ja zweifellos braucht. And
we can't solve the problems by ramping up water. We can only cure the symptoms in the short term. But we have to make sure we can manage in the long term and work with nature.
Langfristig zurechtkommen und mit der Natur zusammenarbeiten.
On Spitzbergen, Fika Rade and Marion Matorilli are on their way to a field outside the research settlement New Allesund. They're investigating a piece of land that used to be frozen all year round.
Now in early September, the ground has thawed the furthest. But it is very uneven here. Every point in the earth is a little different.
Once a month, Fika Rade has to drive the rods into the so-called permafrost to see how far it has thawed in the meantime.
Can you see if the bar is still moving and hold it? Okay, here the impact depth is 95 centimeters. We would actually expect more based on the temperatures. But as I said, the ground here is very uneven, and there are many differences. That's why it's important that we measure this over 12 different points and always measure about the same hole. So we know very precisely how this specific hole changes.
Fika also has to change a filter today that collects CO2 released by the thawed ground.
There's a sieve in the tube that stores the CO2 that comes out of the soil. And that's where the scientists can look to see what kind of CO2 it is, whether it's CO2 that's been released by plants that are growing here now, or that are fresh in the soil, or whether it's CO2 that's been released by the soil itself. So a very old organic material that's been in the soil for very many years and can now also be released because of the warming.
Thawing soils continue to drive climate change.
There are exchange processes between the soil and the atmosphere, partly of gases, but also partly of heat and moisture fluxes. And that in turn also has an influence on the climate and the processes that are reflected in this coupled system of atmosphere and soil.
Climate change has changed the wind, and the changed wind continues to drive Arctic warming. Glaciers and sea ice are in retreat. The jet stream will weaken more often as a result. Heat waves with crop failures and dying forests are becoming more likely, as are catastrophic heavy rain events. But there is still time to contain the extent of this.
Fortunately, we're no longer dependent on burning stuff to generate electricity. We can do that with photovoltaics, with wind. We don't need that for heating either. We have heat pumps. We don't need it for cooking either. We have induction stoves. That's the main factor, getting out of fossil fuels quickly and using these alternative energies. For the Paris targets, 1.5 and 2 degrees, we need to go even one step further. We need to make sure greenhouse gases are taken out of the atmosphere to reduce greenhouse gas concentrations.
One way to get greenhouse gases out of the atmosphere is to increase the global forest area. Mattis Janssen and Heiko Schulz from the Mecklenburg-Western Pomerania State Forest are on their way to reforestation work at a former spruce plantation near Schwerin.
Now we're in the process of establishing a new stand here. We are now doing this with hardwoods. For example, our colleagues are now in the process of planting red oak because we simply want to establish a stand that's better equipped for the coming conditions, for dry summers, for further periods of drought. We simply no longer rely on spruce and certainly no longer on monocultures, so that a mixed deciduous forest is to be created here. Everything going according to plan? Good planting material? Are the roots okay?
Reforesting the forest area means a lot of work and high costs. Decades pass before the targeted logging of individual trees recoups the money for the timber industry.
We don't have the tree species that's going to do it in the future. There are certainly tree species that we suspect have good conditions in these changing environmental conditions, in the dry summers, these dry periods, these extreme heats. We know that. The strategy is rather to bet on a colorful bouquet to spread the risk, to bring different tree species.
Reforestation here will not increase the world's forest area. It's a matter of repairing the damage. This is urgently needed to stop climate change, but it's not quite that simple anymore.
If you look at the current climate models and projections, some of which look very bleak, you really worry about which tree species we can really bring in the future. Which tree species will really still make it? What will the forest really look like in 2100? Will it only be a matter of somehow preserving the forest and storing CO2? Perhaps the economy will then also move in the background significantly.
At the Karlsruhe Institute of Technology, researchers are looking for a way to extract greenhouse gases from the atmosphere and use them. Professor Dittmeyer's group is collaborating with various companies to do this. This system from a Swiss company sucks in air and passes it through a filter.
On this filter sit chemical molecules that can form a bond with the CO2 in the air and also form a bond with the water vapor. That is, these two components are separated from the air. Then at some point this filter is loaded and they lock the door, so to speak, front and back. And then this collector is heated. This causes the CO2 and also the water vapor to come back down from the filter and be extracted. Then the water is condensed out and then you have pure CO2.
Dann kondensiert man noch das Wasser aus und dann hat man das reine CO2.
Carbon monoxide is isolated from the CO2 and enriched with hydrogen. The mixture contains a high amount of carbon, the basis for all fuels for combustion. The CO2 from the atmosphere is intended to replace oil, gas and coal.
The real art is to achieve high energy efficiency in the conversion. We put in renewable electricity, produce an energy carrier, which of course contains a certain amount of energy and the rest is loss. And if you couple the individual process steps that we have here, then you can achieve high energy efficiency.
Here an installation does virtually the same work as energy plants, namely filtering CO2 from the air and replacing fossil fuels in a climate-neutral way. So far, however, such technical solutions have been extremely costly.
I believe that this method is indispensable for combating climate change, as we have no real alternatives to kerosene for certain applications, such as long-distance air travel. And if I synthesize the kerosene using CO2 from the air and renewable electricity, then I basically have a cycle. When it's burned, of course, it creates CO2 in the atmosphere again. But since I've extracted my CO2 from the atmosphere with renewable electricity, I have the opportunity to provide that as best I can.
On his fields in Lower Saxony, organic farmer Jan Wittenberg has been practicing agriculture that protects the soil, environment and climate for years. He also takes the changing wind conditions into account, with trees.
Especially with such a wind, you can well imagine that a wind-breaking row of trees is also quite good when there is drought. The soil simply doesn't fly away talking about wind erosion. On the other hand, the trees bring up water and nutrients from greater depth in order to then deposit their fruits and foliage again. That means that this also generates humus, and of course the field can also benefit from this in the long term.
Agroforestry is the name of the combination in which rows of trees are planted in the fields, a concept for which Wittenberg leaves parts of his cultivated land to the trees.
We want to plant 3 beautiful large linden trees here, and we want to do that as a signal for the state, for our combination of tree strips, arable land and grassland. And they stand here, right on the border between grassland on the one side, which is being newly created on former arable land, and our arable land.
Jan Wittenberg is a pioneer. He's long since started to adapt his farming to the new conditions brought about by rising temperatures and a changing jet stream. Simply carrying on as usual is not an option for him.
We see what we have done to ourselves. We are changing the climate, for example. We simply have to deal with the consequences ourselves. That means we have to change. Of course, we have to make a huge effort not to change the climate even more. But we've already created facts, and therefore it's up to us to adapt. And for that, we need new ways. It's no use if you always follow the old paths and hope that fate will help you.
Changes in the jet stream have become a dangerous driver of climate change. It is driven by greenhouse gases that humans continue to produce.